We now want to introduce ourselves to the idea of ratio and proportions. Now, we first want to take a look at a couple of definitions. First of all, a ratio is the quotient of two quantities with the same units. For example, if you wanted to look at a football team's win-loss ratio, you might say that they have a 10 to 3 win-loss ratio, and that's one way to write it, just with the word 2 in between. Or you could write it as a 10 and put a colon in between, and you can write it as 10 to 3 using that notation as well. Now, even though those two notations are technically correct, the notation that we will typically use for our ratios would be a fraction type notation. So there's another way to write a 10 to 3 ratio in a fractional form. Now remember, a ratio is always a quotient of two quantities. So if you had another team that had, say, a 12 to 1 ratio, when you write it in the fractional form, 12 over 1 or 12 to 1, you would never want to simplify that and write it as just a 12. Even though the fraction 12 over 1 is 12, that's not the way we want to write it. We always want to keep the two quantities, so you have to keep that 1. We also, within our ratio, are going to prefer to have whole numbers, so we would not typically want to leave something as like a 3.5 to 1. You're going to write that as 3.5 over 1 and then rewrite it as 35 over 10. And then what this brings us into is how simplification is performed. Simplification of a ratio is performed in the same way that fractions are simplified. For example, in this fraction, 35 over 10, and we can put it into the calculator as a fraction, ask the calculator to turn it into a decimal, and then when the calculator turns it back into a fraction, it'll tell us that that is actually 7 halves. So 35 over 10 simplifies to 7 halves. And again, remember that our units need to be the same. If we had a ratio of $50 to $60, we would write that as a 50 over 60. Note that the units are the same, therefore they cancel, and this would simplify down to a 5 to 6 ratio. Now, something that usually is thrown in with ratios are some things called rates. What a rate is simply a ratio where the units are not actually the same. So if you're looking at something like, say, 400 miles over 8 hours, when you simplify that, you go to the calculator, you take the 400, you divide it by the 8, and that should come out to be 50, and so that is 50 miles per 1 hour. And again, technically speaking, that is not a ratio, that is a rate, because these two units are not the same. Now, if you run into a situation and you're being asked to simplify, and the units are, and you're being asked to simplify a ratio, again, remembering the units have to be the same, and they're not the same, sometimes you have to do a little bit of conversion. For example, if we had 6 feet to 4 yards, and you're asked to simplify that ratio, again, remembering that the ratio has to have the same units, is what you would do is step aside and take the 4 yards and say 4 yards times 3 feet in a yard is 12 feet. So you would rewrite this as 6 feet to 12 feet. When it goes into the fractions to 6 over 12, which is a 1:2 ratio. So always remember those units have to be converted if they are not the same in a ratio until they are the same. In a rate, they don't have to be the same. Now the next thing we look at is a proportion. In a proportion, what that means is you have an equation, and in the equation, two ratios, or possibly rates, have been set equal to each other. When you set them equal to each other, you have to set them equal in a very consistent fashion. In other words, if you were comparing gallons to minutes in one ratio, when you set up your proportion, the other ratio also has to be gallons to minutes. And again, those are actually rates since the units are not the same. If you're comparing miles to hours in one rate, then again, when you set up the proportion, it's got to be miles to hours all over again. So remember, you really have to be consistent when you're setting up these ratios, rates, and especially with the proportions. Now, when we want to solve a proportionality, the technique we use is something called cross multiplication. And cross multiplication, like I said, that's what we use to solve proportions. Cross multiplication involves two multiplications. Our cross multiplication rule says that if A over B is proportional to C over D, then we can cross multiply, and that means multiply across numerator to denominator. And we say that A times D will be equal to B times C. Let's put some numbers with this and see how this works. Let's say we had an X over 8 proportional to a 24 over a 48. Our first cross multiplication should be the one that catches the variable, and we're going to have a 48x equaling, and over here we're going to have an 8 times 24, which is 8 times 24. That turns out to be 192. The last step is always to divide away whatever coefficient the variable has. So when we divide by 48, go ahead and just hit divided by 48. That turns into a 4. So our x in this case is our 4. So our cross multiplication has solved that for us. And it doesn't matter whether the variable is on the top or the bottom. Numerator, denominator, left-hand side, right-hand side, the procedure always works exactly the same way. If I had a 3 over 12 equaling a negative 1.4 over z, the first cross multiplication would be the one that catches the variable. The second one would be the one with the two constants, and I'll take a negative 1.4 times 12, and I get a negative 16.8. And then when I divide by 3, back to the calculator, you just say divided by 3, I get a negative 5.6. What this can actually be used for is solving lots of different types of problems. For example, a lot of different geometric shapes are proportional. Triangles, for example, can be proportional. If I had two triangles and I knew them to be proportional, now proportional doesn't mean the same size. It simply means that the ratios on the sides are in proportion. So if this side was 2 feet, while this side was 1.8 feet, I have a ratio here that will be obeyed by the other triangle. So if this was a 0.8 feet and an unknown length there, I could set up a proportionality. I could say 2 is to 1.8 as 0.8 is to x, Or actually, I could say, another way to set it up would be 2 is to 0.8 as 1.8 is to x. That's as long as you're consistent in the order in which you choose, that's not going to make any difference. I'm still going to have my first cross multiplication of 2x equaling a 1.8 times 0.8, which the calculator can help us with. We take 1.8 times 0.8, and we get a 1.44. And when I go back and divide by the 2, I get a 0.72. So those are the way the proportions are set up, and as long as you're consistent in the setup of these proportions, then you can solve the problem using basic cross multiplication. So that's your basic introduction to ratio and proportion, and your basic introduction to solving using cross multiplication.